So, Vanakkam, we will start our lecture on engineering seismology. So, last class we have been discussing about the zonation, seismic zonation. So, what is meant by seismic zonation and how the proper zonation can be done. Okay, so by concept of seismic microzonation. So, I have discussed the procedure, okay, so which I have developed part of my PhD and explained that so how it is very important to account all the seismic hazards, okay, so in the zonation mapping. So, as you see that the objective of the zonation is basically to give you the data for engineering design, okay, so such as acceleration times t and then the response spectrum and then the design spectrum. So, that is the one main objective. The secondary objective is basically to know that a seismic status of the place, so that the new structure can be designed according to the input developed by that and the existing structures can be retrofitted. Okay. So, this is the main objective, and also for the government agencies to know that what are the places are seismically more risk and less risk to take a decision making to establish important facilities or to make some temporary arrangements or program or meeting, something like that. All those things are. So, this microzonation part as well as the zonation map is very useful. That is what we discussed in the last class. So, you may be seeing that in the last 2-3 days couple of newses regarding the tremors, okay, the minor earthquakes. So, reported in the NCR in Delhi region. So, many people comment about that there is a chances of big earthquake in Himalayan region that may also affect Delhi. So, and then there is these earthquakes may be the foreshock, okay, for the earthquakes which is expected a main event. Okay, so there was a debate. Okay, so some people say that a big earthquake is due. Then how big is the question? Okay, so Himalayan region one can say that a big earthquake means about 7.57 and above magnitude can be expected. Okay, so it's obvious that it's a plate boundary. So where a bigger earthquake is possible. So as per Delhi region concern, okay, so there is these events are foreshock or not. So that is the big question, but it is very difficult to justify that. Okay, so there may be a big earthquake or may not be a big earthquake. As you know that none of the places in the world is free from earthquake, that we have discussed in our previous lectures during discussion about the elastic rebound theory. So according to the elastic rebound theory, so all the places, okay, there may be a possibility of breakage of the rock due to the storing of energy which is created by the plate tectonic moment and rotation of the earth. So that means none of the places are free from earthquake. Only thing, the frequency of the earthquake, some place it may be very frequent, which is similarly occurs in the plate boundaries. So some place it may be a moderate frequent where there may be a fracture happening due to bending of plates and moving of plates. Some place it may have the very large gap. Okay, so that is, so in that scenario, okay, so instead of worrying about that the earthquake going to happen or not, if it happens what will happen, all those things, so keeping aside of that, as we know that it is not possible to predict earthquake accurately. So we have seen when the prediction 9 methods, we have seen that there are some good precautions, but you have to have the 2-3 composite way of understanding the method. Okay, then you can able to at least get a relatively prediction, but we have seen that the wrong prediction, what is the socio-economic problem which impact. Okay, so that kind of scenario is there. So it is always not to worry about the prediction of the earthquake or future earthquake will happen or not. One of the best way to save from earthquake is basically we should see that, okay, so all our structures are designed for the earthquake at least as per IS code. Okay, the IS code is right or wrong or the values are representative are not a different issue. At least if you design as per the current IS code, okay, IS 1893, so 2016 version, so you can at least save from the collapse of building. Okay, so collapse may not happen. Okay, so that is very sure. So people who are designed their buildings, okay, NCR or Delhi region, they no need to worry about that the earthquakes are going to come or not. Even if comes, nothing will happen to you. You are very sure. Okay, so those who are watching these videos, so I want to give this message, since you are studying in engineering seismology, it's better yourself also to understand what we are talking, how it's relevant for the practically. So those who are designed their buildings, apartments or houses or whatever building against the seismic recommendation by the Indian Seismic Code. Okay, so you no need to worry about that the earthquake comes. If there is even a moderate earthquake is possible in the Delhi region, if it comes, you will not get worried about that. Okay, you will have worst case some cracks here and there, you know, but in case your house is not earthquake resistant design. Okay, so your house is not taken care of the amplification, your house design not taken care of the liquefaction in the site, then you have to be really concerned. Okay, because as we said that earthquake may come anytime, anywhere. Okay, since we don't know what was the past history of the particular fault and particular location, it is very difficult to say that when it is going to come. So it better you should be prepared. So that is one of the aspect where your seismic zonation, seismic microzonation concept has been introduced in India. Okay, so when you look at history of the Indian code, which we will be discussing in the little later stage. Okay, so we don't have a very robust advanced seismic zonation map of the country. Okay, which I will explain you later stage why I am talking like that. So in that, considering that after 2001 earthquake, Bhuj, okay, after 2001 earthquake, the government realized that okay, there was many people died in the Bhuj, okay, which was predominantly by the amplification and liquefaction. Okay, and many school kids died. That made a government to concern about that. Then people highlighted that the current zonation practice in the country is not perfect. It is on a macro scale. So we have discussed what is the macro scale. It's basically based on the geology and the seismicity. It is not based on the local soil condition and site effect and liquefaction. So then the government felt that there is a need for doing the microzonation of at least urban settlement where people are accumulated more. Particularly Ahmedabad, many people died, which is more than 250 kilometers from the epicenter of the Bhuj earthquake. So then it was realized that then government initiated the microzonation or zoning study of the country. They started funding the research, okay, so initiative. So that research initiative only held a seismic microzonation of the Bangalore, which was part of my PhD. I have done extensive study where we have developed a streamlined methodology for seismic microzonation. Okay. So today we are going to talk about, as on now, what seismic microzonation is understood by the people and what they have carried out, what they delivered in India. Okay. So even though I have developed seismic microzonation in 2007, there was some work which is done before 2007, some work after 2007. So then there are a lot of research and development, because there are many, even people started doing microzonation study at UG level. Okay, people who study BTech in civil engineering, BTech in earthquake engineering, or anywhere related to civil and earthquake geology, they started doing the microzonation at UG level. I don't know really like 4 months what kind of work you can do. So even a course which is a part of that entire process is itself offered a semester. I am not very sure UG projects are but people start doing that. So we will be highlighting some of the project which is carried out as a seismic microzonation in India. We also highlight some of the classical work which is carried out for the particular urban centers on seismic hazard analysis, all those things in the today class, and continue for the few our extra classes in this aspects. As we told that the zonation is basically division of area, okay, which has a similar earthquake effect, which consider all the aspects which can happen due to the earthquake. That is what we told. So it's basically delineating the area, okay, geographical delineation of the area where there is a all the earthquake effects are similar at that particular location. So this can be done at a different level. We have seen like a macro level, micro level and nano level. So depends upon the input what you give, what is the scale you consider. This studies, there was a ISMG guideline to define a different level of seismic microzonation studies. So which we have discussed in the last class, so you can refer your old notes. So we have seen that, okay, these microzonations are really concerned for the government, because there are many people will die, there are huge amount of the economical loss. okay, so which create a lot of trouble in industry, as well as the lot of money has been wasted for the unpreparedness of this kind of thing. So that's why they thought that zoning up, okay, preparation of zonation map, okay, at a micro scale on each cities are important, which will help for the new design at a particular place, and as well as retrofit the old buildings. As you are seeing that the smart cities, okay, there are about 90 smart cities has been earmarked by the government for the where the small places, cities, small towns are get converted into the urban level, so that people can stay there, and instead of accumulating in the bigger urban which is already exploded beyond its limit. So this will help. So in this also the zoning of that particular city, okay, smart city, okay, will help to identify where you can locate different facilities. We have seen that the location of the important dangerous facility should be, okay, away from the highest risk area. Okay, so we should see that, and hospitals, all those things. So in that aspect, the seismic zonation is a multidisciplinary which should involve a geologist, seismologist, geotechnical earthquake and structural engineer, or the person exposed to all these aspects can be taking up this kind of studies. So generally, if the civil engineers involved, okay, who was exposed to all this aspect and study all this aspect after master level, you can get relatively suitably a representative zonation map, as long as he is experienced and gone through the all the literature about the microzonation. So the microzonation is a subdivision of the region considering the various exposure of the earthquake effect. Okay, that is what we have seen. So we have seen that this is consist of about 7 classical steps. Okay, starting from estimating the bedrock level hazard, then characterizing the soil, then estimating how the waves are get modified, okay, in the form of site response studies using theoretical and experimental approach, then assess the liquefaction. So all this one output will be the input for the next step, and then estimate a landslide possibilities which is highly possible only on the hilly region, and then estimate the tsunami hazard which is only possible on the coastal region. After estimating all this hazard independently and take that hazard and assign a proper weights and ranks, and then finally prepare a zonation map which shows a hazard index and then the design spectrum, acceleration time history. So that people who are willing to design the structure in this region, they will take this input. So recently there was a discussion, okay, so in the one of the NDMA meeting, like a National Disaster Management Authority NDMA meeting. So this microzonation, what was the output, how it is useful for the civil engineering. So why this discussion was taken place, when I discuss the different microzonation studies in India carried out, then you will understand, okay, why this discussion. So we also going to see the ongoing microzonation effort by the Indian government, particularly under the umbrella of Ministry of Earth Science and National Centre for Seismology. That is also we are going to discuss today. So if you see that the seismic microzonation, there are some part which is completed and published as a report to the public, or published by the NDMA, where a public can access this report. So there are some things which is done partially, but NDMA is not officially issued those as a microzonation map that particular city. The city which is completed the microzonation basically Jabalpur, Sikkim and Delhi, and then Bangalore. Okay, so these are all the places. Then Guwahati, these are all the places the work was completely completed. The cities which is done by others but not released as a official record, okay, by the NDMA, but state government was done was like a Mumbai city. So here also given a the brief about the people who are involved on those kind of studies in this slide actually. So then there are people who are done for some specific area from the international funding or their own arrangements in the state level or something like that. The Northeast India, Dehradun. Okay, so there are some cities where the microzonations are people are doing. Okay, so these are all the some of the cities like Bhuj, Kutch, Ahmedabad, Chennai, Kochi, Mangalore, Coimbatore. Okay, so then the Bhubaneswar. So now even the recently 8 more cities are get awarded by the contract to IS or Gandhinagar for the microzonation. So I will give you the glimpse of the some of the major work which is completed part of this microzonation studies. So, let us see the seismic hazard estimation studies in the South India. So, this South Indian seismic hazard estimation actually carried out, okay, so by the many people, but it is not basically a complete microzonation study, but as we have seen that the estimation of the hazard, okay, also a part of your microzonation step. That is maybe the first step to estimate rock level, PGA level. So, there are few places where it was been estimated. So, South India, it was done by the Parvez et al, where he estimated the maximum displacement, design ground acceleration. Then there was a another article where they try to estimate a Mumbai city for, okay, using the hazard curve, deterministic probabilistic approaches, and then the whole southern India by the probabilistic as made by the Jaiswal and Sinha. So, these are all the people, some of them they estimated a hazard values, okay, not any other things. So, this is a part of microzonation, but it is not a complete microzonation or zonation map for the useful for this one. So, as such there is no any classical work which can quote as a South Indian seismic microzonation work other than Bangalore, okay, work which is published and officially released as a book from the NDMA. Okay. Those who are willing to see that book, you can go through. That is almost my PhD thesis. Okay. Maybe my name may be acknowledged or may not acknowledged, it does not matter, but if you see my PhD thesis and that book, it is almost similar because I have done that work part of my PhD, okay, on the seismic microzonation. Okay. So, I am not going to discuss Bangalore work in detail because there are a lot of publications are available. So, I only discuss the others work which what they have done, so that we can compare a methodology developed for the microzonation or what is meant by microzonation and what is the work carried out by others. Okay. So, that you can one to one relate and see what are the improvement needed or how sufficient that work is to represent a zonation map at a particular place. So, in order to make a understanding that, I am going to explain. So, the first microzonation work in this one was actually Jabalpur microzonation. So, this was done basically, there was a severe earthquake of 6 magnitude struck Jabalpur and adjoining area Madhya Pradesh early hours of May 22, 1990, which took around 39 people have died. So, this Jabalpur, okay, after this Jabalpur and Bhuj earthquake, so the seismologists and geologists believed that there should be a microzonation of the particular area. So, then they thought instead of taking a Bhuj itself, because that is that time only the earthquake was happened. So, and this study also initiated a little longer. So, I mean before the Bhuj earthquake. So, then they taken a Jabalpur as a city for seismic microzonation work. So, what they have done, I give you the glimpse of the work what they have done. Basically, they carried out seismic hazard analysis by the deterministic approach. Okay. So, here you should note, because when you are talking about the hazard analysis after completing up this microzonation and Indian seismicity classes in the future. So, you should know what is the deterministic and probabilistic approach, why it is important, I will be discussing, but right now I am just giving the what they have done. So, they carried out hazard analysis by deterministic approach. They used a ground motion prediction equation, which is also called as attenuation equation, developed by Joyner and Boer 1981. So, this work was basically published I think around 2004 or 5, but they used the GMPs which is developed by Joyner and Boer 1981. So, when we are talking about the predictive equation, we told that any predictive equation should be subsequently represent a region and has been developed as much as the new. Okay. So, these people also done a complete ground characterization, which is the second step. They used SPT data and the MSW survey, and they also carried out site response studies by the Nakamura type studies receiver function, where they try to estimate a predominant frequency, which we have discussed what is the predominant, and then peak amplification map. Further, they also assess liquefaction assessment was carried out using the geotechnical borehole using simplified approach suggested by the Seed and Idris. So, even though we are not discussing the liquefaction, site response, site characterization in detail, but you should know that these are the work which is involved in the particular map. Okay, so they published a first level seismic microzonation map. So you can see they are given like the different coding and color where the hazard levels are included. So they found that the hazard amplifications are as high as more than 4 in the 3 to 6 window of the I. 3 to 6 hertz window, and then it also mapped a high liquefaction area. So this is generally done based on the geology. Okay, this map was done based on the geology. So then they updated this map. Okay, so where the geology and also improved by taking into the soil data, where the site response study carried out, amplification estimated, liquefaction estimated. So all this factor together they put together and revised the map. This map they call it as a second level microzonation map. You can see the now the red pattern and then the color change. Okay, so you can see how this was changed the zonation pattern. Okay, that's what the where when you include amplification liquefaction, basically your zonation get altered. So the geology based zonation may not be so appropriate. Okay, so that is the message you can take from by comparing these two. So then the further they also try to estimate a risk. Okay, so by considering the some scenario. So where the pilot project Department of Science, the Geology of Survey, in this work actually who are all involved actually the Geological Survey of India, Central Region Nagpur and the Indian Meteorological Department IMD, NGRI, okay, so Central Building Research Institute. So they almost spend close to like about 4 to 5 crore rupees to take up this work. Total area has been classified 3 zones, okay, low, medium, high with the scale of 1:50,000. So here the overall basic command was that, so even though this was the first work in India, but it is not a first work can be quoted as a example for microzonation. Okay, so I had chance to go through the complete microzonation report during my PhD where it has come for review to the IISc. So where I have been pinpointed all the necessary improvement needed in the report. So then only that the first map what you have seen based on the geology has been improved by including the amplification liquefaction. So finally they arrived, this is the final map which is officially released by the government. Those who are interested you can basically browse and get the details about the Jabalpur microzonation work. Okay, so this given a starting point, kickstart in India, where the next work has been improved considerably by systematically analyzing the procedure and other things. Okay. So the next work what carried out for the seismic microzonation of Delhi. The Delhi was actually carried out by the different people. Okay, they are basically carried out a group of scientists working on different place according to their availability and then interest they carried out. So this was like the Mukhopadhyay, IIT Roorkee, CBRI, then Parvez et al. CMAX, Iyengar and Ghosh, IISc, Rao and Nilima, IIT Delhi, Mohanty. So these are all the people basically they carried out microzonation. Okay. So then later even IMD MOES taken up all this input and then further improved and then they finally released a complete microzonation map of Delhi. Okay. So here the Mohanty was carried out micro tremor steady H/V ratio, Parvez were carried out a hazard analysis and tried to get a spectrum, okay, which based on the past earthquake data, and then Iyengar and Ghosh did a PSHA analysis and tried to give a PGA distribution at bedrock. So when you are talking about the this one you can see basically. So they also consider a soil amplification using the shake. You can see the value of the G value, okay, around see the NCR. So if somebody considers their house design around this, basically your house may not get collapse. Okay. So this was predicted for around like 2004, which is roughly about 15-16 years back. Then Mohanty carried out complete microzonation study and tried to estimate, okay, the H/V ratio. Okay, so when the H/V ratio basically there are some geologists and seismologists believe that doing a microtremor study and mapping a predominant frequency is called as a microzonation. Okay, the microtremor study and a predominant frequency, but as I told you that the predominant frequency will help you only to give the fundamental frequency of the your soil column. Okay. So, this will basically related to the thickness of the soil column, So, that thickness, okay, again depends upon the regional correlation established between the H by V ratio and predominant frequency. So, as such the predominant frequency estimated may indicate, as we have seen that the geology and isoseismal maps are very well matching. Similarly, the thickness of the and failure pattern isoseismal maps are very well matching in the past earthquake. So, the knowing of thickness will help you to know that where the more severe earthquake hazard can be expected for the same earthquake. That is all. It does not really give you the microzonation map, which is required by integrating the 7 steps. There are 6 steps integrating the 6 parameters. It does not give you that kind of map only by using a microtremor studies, because we have been used microtremor study for different cities, and we found that. So, this microtremor study, the predominant frequency and soil function of your predominant frequency and establish a relation between the soil thickness and predominant frequency. If there is a change in this estimation can be completely wrong. Okay. So, one has to remember that, but there are people who carried out this kind of studies and claim that that is the microzonation of this one. So, then the IIT Delhi, okay, the Professor Neelima Satyam carried out part of her PhD, okay, so where she did a complete hazard analysis, liquefaction analysis, site response and characterization using the MSW. Finally, they produced map which shows a different hazard level. Okay. So, they even used a simulated synthetic ground motion, which is useful or required for the site response studies. So, they developed a PGA bedrock map, okay, and said that there are 5 zones can be arrived from this one. Then they measured a soil properties using the SPT and MSW, and amplification studies from the using this data and this input, they carried out site response analysis and tries to estimate. Then they also did microtremor to compare the results obtained from the borehole and MSWs are synchronizing. Finally, carried out liquefaction potential map using the Seed and Idris, Iwasaki and Shake kind of thing. Finally, produced a liquefaction the potential map or liquefaction severity map. So, this is the map. You can see that. So, this is actually the Yamuna river. So, the region which is close to Yamuna river, okay, has a severe liquefaction possibility, you can see here. Okay. So, the people in this region really should concern that their buildings, even though the building, as I said, that the building designed for the earthquake resistant structures, but they did not taken care the liquefaction possibilities in the structure may sink inside the soil or it will collapse or tilt. Okay, that is has to be. So, the severe, then the moderate region, these two are the moderate region. So, the white one as a remote, the another area as a minor. Okay. So, this is the where you can see wherever the river deposits are there. So, this is the place the liquefaction possibilities are there. So, all this combinedly produced. Okay. So, then they finally, as I told you that there is a IMD also working, IMD and other institutes also work. So, finally, they created a liquefaction microzonation map of Delhi, okay, which includes all the like hazard analysis, site characterization, soil data, site response and liquefaction. As the landslide tsunami is not possible in Delhi, so they removing that. So, they carried out a detailed mapping and prepared a seismic microzonation map with 1:50,000 scale. So, you can browse this report where they accounted all the possible hazard. Okay. So, where the depth, the bedrock depth, liquefaction, shear wave velocity, amplification. Okay. So, finally they produce a map which shows low hazard. Okay. So, then a moderate hazard and then high hazard. So, you can see that wherever there was a liquefaction possibility we told. Okay. So, those are all the places are considered to be a high hazard region. Okay. So, in this also wherever the rock outcrop is there, Okay, basically this is a shallow bedrock sites. So where they consider that as a basically a low hazard, as the amplification liquefaction may not happen. So when we discussed about the different type of hazard, we have seen that the amplification ground shaking hazard is basically causing more than 70% of the deadly earthquake in the world. Okay, that is what we have seen. So knowing of this hazard, okay, so it's a very important for the any microzonation study. The map which represents considering this will be the more reliable one microzonation studies. So we as on now the Delhi is one of the classical work which accounts all of them, okay, with appropriate ground motion prediction equation as well as the regional taken into account. Okay. So this was done by the recently updated map was released by the Ministry of Earth Science, where the previous work by Rao and Nilima, Mohanty and Iyengar and Ghosh, all those works are basically integrated. Finally, the microzonation work of Delhi is available. Those who are living in the Delhi, okay, you want to know that what was the your design force at that particular location, you can basically Google it and find out microzonation report, or you can obtain a copy from the Ministry of Earth Science, because it's a publicly funded project. So you can know your region is falls on which category, what is the force is expected in that region, your building is designed or not. So if you know that it designed, then you no need to worry. If not designed, you should really concern and try to improve the buildings area, or if you are constructing new one, you can adapt to this procedure for construction of the new house. Okay. So right now we discussed about the microzonation importance and also the two typical case studies. One is the Jabalpur, another one is the basically your so Delhi region. Okay. So those who are in Delhi, now you will be understand that how severe earthquake in your region, you no need to worry as long as you are designed your buildings are designed for the earthquake. If not, you should at least concern and be alert, so that something happens you will escape. Okay. So with that we basically close today lecture. So thank you very much for watching this lecture. We will meet you in the next class. Thank you very much.